Hello everyone, a very good afternoon. Today me and my team, we are going to conduct the road safety audit for our course ECG563 Traffic Engineering. And this is the location that we have chose, which is the Bukit Tonggek.
Okay, firstly, I would like to discuss about road conditions. As you can see, the road conditions is in bad shape because right here, you can see that there are lots of patches causes from all potholes. And there is also lots of patches. From these patches, it creates uneven surface that can affect road's user, which may increase the dangerousness of road user.
The next identifiable problem in this location that we have chose is that there is no blind spot mirror located at the intersection. This will cause the drivers to not be able to predict the users coming from that road to the intersection, which can cause accident at the intersection.
So the next problem is, as you can see, there's no guardrail along roadside. Guardrail is very important so that it can prevent car from moving away from the roadway. As you know, guardrail is a very important safety features to help prevent car from moving away from roadway, especially at steep hill.
So today I would like to talk about the importance of road safety. So in this area there is no signboard limit. So for example, there is no speed limit, which can cause the driver may travel too fast without know the appropriate speed from this hilly area, and then the driver also can don't know about this area is hilly area where they can cause the speed can travel fast when going to the down of the hilly this area. So in this area we must put the signboard such as the speed limit and the slow sign and the hilly slope sign.
Based on our data collection, most vehicles passing through this road travel at higher speed than the speed limit, which is 30 km per hour. As you know, 30 km per hour is the speed limit imposed on an institution. Higher vehicle speed increase the risk of accidents, especially on this road section due to absence of safety features such as guardrails and due to road section to its slope. 3.
Okay, the next problem that we have identified in the location is that there are overgrown vegetation. As you can see on the road here, there are some vegetation growth on the road, which could cause for example, when a car pass through this road at night, they might skid due to this surface, which is not designed for the road users lah. Okay, as you can see on the main point, the vegetation problem. As you can see, the tree is blocking the lighting of the lamppost, which would cause this area to be dim and which would increase the likeliness of the cars passing through this road to experience an accident.
As you can see, there is a malfunction in street light. So this may be dangerous to the driver while they drive at night. So this is because it was the difficulty to visible during drive at night, where they cannot see the pedestrian or any other dangerous object or the cyclist during drive at night.
Next is walkway marking. As you can see here, on this hill there are no walkway marking. It doesn't indicate that is it one way or two way for vehicle user on this road. This can cause confusion among road user, which later it can causes other road user to invade other lanes and causes an accident.
Yeah. We want to set this person as the initial starting point, and he'll be the stopwatch timer guy. And next we will start the point here with the major wheel. Okay, first we want to set for 50 meter. He will be point B, whereas the person behind will be point A. And then when this guy say that a car is coming, the person at point A will be the one giving the timer, starting the timer. And from there, we will measure the time taken from this point to that point to find the velocity. Okay, now we will be doing the automatic method. So he will be using the radar gun to point at the moving car to determine the velocity, the speed of the car. Now as you can see, it shows the result, and that's how we do the automatic method.
Okay, so now I want to talk about the result and data analysis for our lab. So first is spot speed using manual approach. Based on our sample 25 vehicle, the arithmetic mean speed is 19.8 km per hour. And the modal range is within the 16 to 20 km per hour with a standard deviation of 6.46 km per hour. Okay, for now is spot speed using automatic method. Our automatic radar gun data for a 25 vehicle reveals an average speed of 19.8 km per hour with a median of 18.3 km per hour. The primary modal speed range falls between 16 and 20 km per hour with a standard deviation of 6.62 km per hour. The next is for graph tabulation and comparison. Now, for the bar chart, this chart is compare the vehicle counts across speed range for both tracking methods. As you can see, both the manual and automatic method shows a highly synchronized distribution pattern. Traffic clearing peak within the 16 to 20 km per hour range, where the automatic radar gun captured 9 vehicles and manual tracking recorded 8. Okay, now I want to present S-curve graph. Looking at our combined S-curve, both tracking method align near perfectly at the critical altitude percentile mark of 27 km per hour, which is our golden standard for engineering design. The slight divergence we see in the midsection where the manual median is 18.3 km per hour versus the radar 16.7 km per hour. So this is simply highlight minor human reaction lag in manual timing. Ultimately, our tight standard error prove this data is highly reliable for traffic planning.
Now, let's move to the conclusion. This road safety audit at the selected vertical curve section identified 9 key safety deficiencies: patches and pothole-ridden road surface, missing blind spot mirror, absence of guardrail, missing signage, vehicle exceeding the recommended speed limit, overgrown vegetation, malfunctioning street light, absence of marking, and inaccurate cross-section. Here are the 6 proposed mitigations. Number 1, resurface the road and carry out routine pavement maintenance. Number 2, install a convex blind spot mirror and guardrail along the curve. Number 3, add curve warning and speed limit signage supported by rumble strips. Number 4, trim overgrown vegetation to restore sight lines. Number 5, repair street lights and repaint road markings. And lastly, redesign the cross-section in line with geometric design standard. For the overall impact together, this measure improve visibility, driver behavior, and structural safety at the audited site, directly supporting SDG 9 which is Industry, Innovation and Infrastructure, and SDG 11, which is Sustainable Cities and Communities, by creating safer, more resilient road infrastructure for all users. Thank you.